Welcome students and good day to all. In today's class we would be learning how to integrate the Gaussian integral. I've already done a video on integrating Gaussian integral, but the previous video or the previous lesson that is meant to show you the integration of Gaussian integral was handled using the Jacobian. But in this class we won't be utilizing Jacobian, but we will be just applying the straightforward integration technique and evaluating the Gaussian integral. So foremost what I wish to do is I would like to let I be equal to integral negative infinity to infinity e raised to the power of negative x squared times dx. Now this is even function, so I can rewrite this as 2 times integral 0 to infinity e raised to the power of negative x squared dx. So if I were to consider I, let me write it over here. So let us consider I multiplied with I, right? If I were to consider I times I, then what is going to be the outcome? Now on this end I have written this left hand side is equal to 2 times integral 0 to infinity e raised to the power of negative x squared times dx. Now the result that we get here will not have any impact if I were to change the x variable to y. In other words, what I'm saying is the value that I get for this integral will also be the same value that I would get if in case the integral is e raised to the power of negative y squared times dy, with the 2 being there and the limits are unchanged, because the outcome is going to be a numeric quantity for this. The same numeric quantity will also be obtained in spite of we having a y variable, so there won't be any differences at all. It doesn't matter, you can have here as x and here as y, here as x as here and m or n or anything for that matter, but I am taking here to be as y for simplicity. So having mentioned you that important concept, let me consider now I multiplied with I. Now for one I am going to utilize this integral 2 times 0 to infinity e raised to the power of negative x squared times dx. For the next I am going to utilize 2 times integral 0 to infinity e raised to the power of negative y squared times dy. Now if I were to club these two quantities, right, I hope you got that. For the first I am utilizing 2 times integral 0 to infinity e raised to the power of negative x squared times dx. For the second I am utilizing 2 times integral 0 to infinity e raised to the power of negative y squared times dy. Now I am going to club these two quantities. 2 and 2 will give me 4. Now when you are clubbing you need to be careful, because this would be the inner integral and this would be the outer integral. Of course we can write e raised to the power of negative x squared times e raised to the power of negative y squared together, right? But when we are placing the inner integral, the first quantity that will come in is dy. That is important, and the limits are 0 to infinity. The outer integral will be dx and the limits are 0 to infinity. However, the limits aren't any different, so that wouldn't have an impact. But when you're writing, you need to be careful that dy is the inner integral, which is operated on first, followed by the outer integral, which is dx. Now I can very well club these two quantities, because a raised to the power of m times a raised to the power of n, this is going to be equal to a raised to the power of m positive n. So with this is equal to 4 times, limits are 0 to infinity e raised to the power of, now this is going to be negative x squared negative y squared times dy times dx, which can be rewritten as 4 times 0 to infinity e raised to the power of negative of x squared positive y squared times dy times dx. Now this is where the all important substitution comes into place. Now what I wish to do is I would like to make the following substitution. For y, I am going to take y to be equal to x into t, and x is a constant but t is a new variable, so this would mean we need to study the limits for t. So t is equal to y over x. So if I were to take dy, my dy is going to be, x is a constant and the variable is t, so dy is going to be x times dt. Now let me place in the limits. When y is equal to 0, t is equal to 0. When y is equal to infinity, my t is equal to infinity. So there wouldn't be any change in that case. So all we need to do is just place the values. So this is equal to 4 times integral 0 to infinity integral. This is t variable. So just to be a little bit comfortable, you can place t is equal to 0 to t is equal to infinity, and e raised to the power of negative. My x squared stays the same, but my y is xt. So y squared is going to be x squared times t squared times my dy is x times dt followed by my dx, right? So this is what we have got. Now you can rewrite this as 4 times integral 0 to infinity. You don't have to place t now because it's already there. So 0 to infinity is sufficient. Now you know the limits are actually for t. And what I wish to do is I would like to take my x squared out. Now you might be wondering, why am I taking x squared out? I will tell you in a minute. So I'm taking x squared out and I'm going to write this as 1 positive t squared times x times dt times dx. So the integration is with reference to t, right? Because we have the differential operator dt. Now you can see the quantity is e raised to the power of negative x squared times 1 positive t squared. If I were to integrate this with reference to t, with the differential operator being dt there, it would be very complex. I don't want to do that. But I wanted to simplify the question. I wanted to simplify this system. So the best way to simplify is it would be much better if this dt and dx are reversed. Are you following me? The ideal way to get the outcome, if the operator happens to be dx first and dt next, right? So I'm talking about a flip, but that is not all the time, or I should say it is not as easy as I'm telling, right? I can simply say it, but to achieve that operational change, I need to utilize an all-important concept, what is called as Fubini's. Okay, Fubini's theorem. Now what is Fubini's theorem says? I am able to change the operator dx followed by dt if and only if this entire thing is continuous. This function or this system which we see here ought to be continuous. Now clearly this is continuous, right? Because of the fact this is continuous, by Fubini's theorem I can safely flip the integrals, and my new change is going to be e raised to the power of negative x squared times 1 positive t squared times x times dx times dt. So this is my new integration, and the limits are for x 0 to infinity. The limits are for t is over here 0 to infinity, right? So I need to integrate this. My page has run out. I need to move to the next page. Please bear with me. So we are on a new page, and this is what we had in the previous page. So what I'm going to do, I'm going to integrate this quantity. So and it has to be integrated with reference to x because of the presence of the dx operator. And I already explained to you how I was able to flip the operational impact of the variables dx and dt. So let me make the substitution. So what I wish to do is I would like to make the substitution as, say, for example, x squared times 1 positive t squared. 1 positive t squared is a constant, x is my variable. So I'm going to take this as some u, and this is going to be, if I were to differentiate this is going to give me 2 times x constant. You just bring it, retain it as it is, 1 positive t squared followed by dx is equal to du, and x times 1 positive, in fact it is better that I don't take 1 positive t squared. I was thinking of making a complete substitution because this 1 positive t squared would become, but anyway, since I've taken it, it doesn't matter. I will take care of it later on. So coming back, I have to, so let me write this down. 2 times x 1 positive t squared. I need to have only dx. I am just repeating this step because my concentration got deviated a bit. So I need x into dx. So what I'm going to do, I need to push this down. So du over, I'm going to bring in 2 and 1 positive t squared. So this is the constant, but we don't have the constant there, right? So I'm just going to make the substitution for xt dx over here. So this is equal to 4 times the limits. When x is equal to 0, everything will be 0, right? Let me substitute the limits there. When x is equal to 0, we're talking about u will be equal to 0. And when x is equal to infinity, u will be infinity. So there won't be any change at all. So this is going to be 4 times 0 to infinity, integral 0 to infinity, e raised to the power of this x squared times 1 positive t squared is u. I got a negative sign, so place the negative sign. X dx is going to be du over 2 times 1 positive t squared. This is a constant, so you can just simply place that, right? So now the question is, I have to integrate this. So I'm going to rewrite this as 4 times integral 0 to infinity. Let me, in fact, 2 can reduce 4. That's going to be 2 there. 2 divides 4 2 times. So 2 times integral 0 to infinity. And I have a 1 over 1 positive t squared. That's a constant. Now if you have to integrate this, this is going to give me e raised to the power of negative u with a negative sign, right? Followed by the limits 0 to infinity. Of course, I'm going to place this dt over here outside. So first let me just tackle the limits. Right, let me just tackle the limits. Now if I were to place the upper limit, what happens? Now to be on the safe side, let me just take the negative sign out. So it's going to be negative 1 over 1 positive t squared. It's taken out. And upper limit, if I were to place negative infinity, that's going to be 0, followed by e raised to the power of 0, right? And then you have this dt here, and then you got the limit 0 to infinity, and you have a 2 there. Okay, that's fine. Now this is going to be 0, this is off, this is going to be 1, negative, negative, positive. So now what you got? You got 2 times integral 0 to infinity. As I mentioned to you, because of the presence of a negative sign and a negative sign here, we are going to have a positive value. So it's going to be dt over 1 positive t squared. This is what we have got. Now what is this? Integral 0 to infinity dt over 1 positive t squared. This is nothing but tan inverse of t. And the limits are 0 to infinity, and you got a 2 there. Now you substitute the upper limit. This is going to be tan inverse of infinity, followed by negative tan inverse of 0. Now this is going to be 0, but this is going to be pi by 2. So 2 times of pi over 2. My 2 and 2 gets cancelled, giving me pi. But what you got on the left hand side? You got I squared. So I squared is equal to pi. Therefore what is I? I is equal to root of pi. And this is the value. But what is I? We started with I, so this implies integral negative infinity to infinity e raised to the power negative x squared times dx is equal to root of pi units. So this is the all important Gaussian integral, which has been evaluated without the use of Jacobian. Thank you everybody, enjoy your night.